Get started now, just so that we can not end at like 10 in the evening. So today we'll be reviewing data types in Java. The whole chapter is kind of beefy, so we'll go ahead and jump right into it. Let's begin with our first section, which is Java data types. Static versus dynamic typing. In a dynamically typed programming language like JavaScript or Python, you should have had experience with Python by now. Well, let me check. Okay, yeah, we're good. A variable or parameter can refer to a value of any data type. So you don't have to say, hey, this string is a number, this string is text. You just do let, and the language just lets you put whatever in there. When the variable is used, the interpreter figures out what that type is and behaves accordingly. So what this means is essentially if you do let car equals A, then the interpreter figures out what it is, whether A is a string, a number, a date time, etc. So Java is a statically typed language. So when a variable or parameter is declared, the data type for the value has to be specified. Once the declaration is made, the variable or parameter cannot refer to a value of any other type. So this bit here is legal in JavaScript, which is dynamic. You have let dynamic variable equal dog. If you do a console log of type of dynamic variable, you'll see that it is a string. Then you reassign dynamic variable to equal 42, and if you console log it, then it's a number. So after line 1 executes, dynamic variable holds a string. After line 3 runs, it becomes a number. A dynamic variable is allowed to hold multiple values of different types, which can be reassigned as needed when the program runs. However, this right here will actually result in an error in Java because int can't be converted to a string and vice versa. So we must declare the type of every variable and parameter in a statically typed language. This is done by declaring the data type for the variable or parameter before its name. So, like we did above, string static variable equals dog. We only need to specify the type of variable or parameter when declaring it. Further use of the variable does not require us to identify its type. So, dynamic and static typing are examples of different type systems. The type system of a programming language is one of the most important high-level characteristics that programmers use when discussing the difference between languages. Here's a few samples of popular languages falling into two categories. So dynamic, that's your Python, Ruby, JavaScript, PHP. That's where you're allowed to just use let or do something similar. Your statically typed languages are much more strict. Those would be your Java, C, C++, C#, and TypeScript. So let's go ahead and continue. Where's my page? There we go. Perfect. Okay. So strings and single characters. So number 1, immutability. Strings in Java are immutable, which means that the characters within a string cannot be changed. So, and single versus double quotation marks. Single versus double didn't really matter much in JavaScript just because we were using either or really. It was kind of like the wild, wild west. Here, it does make sense. It does matter. Java syntax requires double quotations when you're declaring a string. Like dog would be wrapped in double quotes. Whereas there is another variable type, char, which is used for a single character, which uses single quotation marks. The single character can be a letter, digit, punctuation, or white space tab, like /t, which is a new tab, or new space. Manipulation. So here we have some of the common string methods available in Java. So if we have string str equals rutabaga, char at, and then the index returns the character at the index 3. So for rutabaga, it would be A. Now, like most programming languages, Java will start counting from the 0 index. So 0 is R, U is 1, T is 2, A is 3. That's why character at returns 3, returns A. So substring returns whatever string is based out of your beginning index and your ending index. So if you submit str.substring2 to 4, it will go to the second index, which is 0, 1, 2. The second index is t, through the fourth, which is 3, 4, tab. So that's why that returns that. Length, as we are well aware of, just returns the length of a string. Index of A actually returns the exact index of whatever string you are passing in, but it will only return the first instance. So if you have rutabaga here, you'll see it gives you that the third index is A, but it ignores the fifth and the seventh, I think. That's because it only worries about the first. So if you had A as a string, it would only worry about that very first A and return the 0 index. Everything else would be ignored. Split splits a string into sections at each delimiter and stores the sections as elements in an array. I actually haven't seen this one yet, so that should be interesting. We can work with that later. String.concat, string2.concat string3. So concatenates only 2 strings. To join multiple strings, method chaining is required. So if you do str.concat, let's say string was rutabaga and string2 had the value of peas. So this would concatenate rutabaga and peas with no space between them. So important to know that difference. Now it will only concatenate 1 plus 1, but you can do your method chaining to concatenate more than one value. Hopefully everyone kind of understands where I'm coming from with that. So string.trim removes any white space at the beginning or end of the string. So if you had like a tab, a space, whatever at the beginning or end, trim would get rid of that. 2 uppercase and 2 lowercase. All it does is just change all of the string either to uppercase or to lowercase. String.contains text searches the string for specified text and then returns either true or false. So let's say that my string here is rutabaga and I want to see if the string tab is listed on there. I would do str.contains in double quotes tab. Remember, we're using double quotes because that is a string, and that would return true. And then str.equals just compares strings for equality and returns a boolean. That's the same as saying string 1 equals house, string 2 equals house, and then just saying string 1 double equals string 2. vum.ngo. I'm afraid I don't understand that, but thank you for tuning into the chat. If you can explain a little more, I'd love to get into that. Okay, so for now, and I am so sorry, but I cannot pronounce your name. So for now, we will explore the difference between using double equals and dot equals when we discuss Java operators. For now, just use dot equals if you need to compare 2 strings. And we're going to go into primitive types. So a primitive data type is a basic building block. Using primitive data types, we can build more complex data structures called objects data types. And everyone here should already be somewhat familiar with objects, so that shouldn't be anything new. Java uses its own set of primitive data types. The table below shows the most commons that you should encounter. You can find a more complete list at the Oracle website, which is linked up here. So you have byte, short, int, long, double, boolean, etc. But for now, just know int is a positive and negative whole number. Float is positive and negative decimal numbers with up to 7 digits. Double is positive and negative decimals with 15 to 16 digits. So a double is longer than an int. Char is A or 9 or N. Just a single Unicode character enclosed in single quotes, and a Boolean is a true or false. Now in Java, Boolean are not capitalized. I believe in JavaScript, I don't think they were either, but just in case you were capitalizing, so now you know. So, as we'll see in later sections, the float data type sacrifices some accuracy for speed of calculations. So 1.111111 plus 3 results in an answer of 4.11097 instead of 4.11111. Anytime you need to perform calculations with decimal values, you should consider using double instead of float. Okay, now non-primitive types. Primitive data types are immutable and can be combined to build larger structures. So if you have a string that's launch code, so one example is forming the string launch code from multiple car values. The L is considered a car, the A is considered a car, the U is considered a car throughout the entire spelling. String is a non-primitive data type, also called an object type. As we saw in the string table above, object types have methods which we can call using dot notation. Primitive data types do not have methods. So primitive data types in Java begin with a lowercase, while object data types in Java begin with a capital letter. We will explore the array and class object types later. For now, all you have to think of it is kind of like Legos. So your primitive data types, like car, A and 9 and N, those are your primitives. They are part of an object type, which is your string. And essentially, when you create a string, you're just creating a series of primitive types. So LAUNCH, and that's why you can do the above methods here, like string.charAt, string.substring, etc. It's because essentially you're creating an object of whatever you're passing into it, so you can then use the object methods on it. All right, auto boxing. There may be situations where we call a method that expects an object as an argument, but we pass it a primitive type instead, or vice versa. In these cases, we need to convert the primitive type to an object or convert an object into a primitive type. In older versions of Java, it was a programmer's responsibility to convert back and forth between primitives and objects. Converting from a primitive type to an object type was called boxing, and doing object to primitive is called unboxing. So here we have int some integer equals 5. That just initializes and declares and initializes the variable some integer. Line 2 converts the primitive int to the integer object type. So integer some integer object equals integer dot value of some integer. And line 3 actually calls the class name dot method name and some integer object. If method name expects an object type and we send it an int instead, we would get an error message. Simple enough. Now let's assume that a method returns a random number of integer type and we want to convert it to an int type. So we have int our number equals 5, integer random number equals class name dot random number generator. This is not actually something we have currently. This is just for the sample. Int random int equals int random number, and int sum equals our number plus random int. So line 2 declares and initializes our random number as an integer type, and line 3 here converts random int number to an int and stores the value into the random int variable. Okay, so converting between data types in order to pass values between methods quickly becomes tedious and error prone. With new versions of Java, the compiler is smart enough to know when to convert back and forth, which is called auto boxing. For us, the consequence of auto boxing is that in many situations, we can use primitive and object types interchangeably when calling methods and return data for those methods. So it's best practice to use primitives whenever possible. The primary exception to this occurs when storing values in collections, which we'll learn about in a future lesson, but we've already gone through collections. Those are your arrays, etc. So each of the primitive data types has a corresponding object type. Int is integer, float is float, double is double, char is character, and boolean is boolean. So let's do our check our understanding. Which of the following is not a number data type in Java? Number, int, float, and double. Would anyone in the chat like to take a crack at that question? Well, tell you what, let's actually scroll up because we have our reading right here. So we're just going to do here, open up Command F, and number. Oh, that doesn't work. So let's just scroll up. Okay. So int is not it because it does represent number. Float is technically not a number type because it is actually a decimal, which technically is kind of a string that's also a number. It's a weird gray area. And name the Java method responsible for checking string equality. And that was actually near the top. But if we swing back up here, we should see dot equals, which is answer C. So let's continue some Java practice. So let's move beyond our hello world sample and explore a simple temperature conversion program. We want our function to convert a Fahrenheit temperature to Celsius. So first we're going to open our temp converter in the Java Web Dev Exercises project in IntelliJ. So let's see. Okay. So here you should see my IntelliJ pulled up. Let's go ahead and open back our page here. Okay. So here we have some Java practice. We're going to open temp converter, which is really okay. Right here. And let's see. Where is temp converter? Data types. Temp converter. There we go. Okay. So here we have our class package import public class temp converter, our public static void main string args. Now, here we have three different pieces that I want you to pay attention to. We have a double, which is Fahrenheit. We have another double, which is Celsius. And then we have scanner input. We'll go into scanner in a few seconds. I just kind of want to continue along with our walkthrough. So here's what our file will look like. We have to analyze the statements. So we have to build and run the program and verify that it works. So entering 212 Fahrenheit should yield 100 degrees Celsius. Let's confirm that. So let's just run. And let's see. We need to enter 212. Okay. There we go. Okay. So we'll enter 212. And yeah, it actually returned the correct information, which is the temperature in Celsius is 100 degrees Celsius for 212 degrees Fahrenheit. So it's working as expected. Let's swap back over to our course browser. Let's see. There we go. Perfect. Okay. So we have several new concepts in this sample. First and foremost being Java packages, import statement, declaring variables, and collecting input with the scanner class. So let's see. Okay, let's go ahead and continue with that. So Java packages. Line 1 of the program above declares the package in which the file resides, which is referring to, let's see if you can actually see this. This line right here. Okay. Now, for this simple program, your code could run without this line. However, you want to get used to always declaring the package of your Java classes. Packages help to encapsulate code. Encapsulation refers to the practice of shielding your code from outside influences. It's an essential component of good object-oriented programming, and package declaration in Java is just one application of this principle. Without declaring a package, a Java class exists within the default package. In larger applications, leaving all classes in the default packages risks naming conflicts and bugs. Okay, import. The import statement in Java allows us to access the class, methods, and data stored in a different file. Import tells the compiler that we're going to use a shortened version of this class name. In this sample, we're going to use the class java.util.scanner, but we can just refer to it as scanner, as we can see right here. Let's see. Import java.util.scanner, which is what we see. All right. The idea bears repeating in Java. You can use any available class without having to import it, but you must use the full name of the class. Available classes include all of the classes you define in .java and .class files in your current directory, and all the classes that are shipped with the software. So you can technically remove that import statement and change the scanner on lines 9-11 to this. The program should still compile and run. Let's just try that. Okay, so let's just comment. Oh, nope, did not mean to do that. There we go. Commented that out. And 9, we're just going to paste that. And here, we're just going to do this. We're going to save file, save, and we're going to run again. And now let's see, 212 degrees Fahrenheit should be 100 degrees Celsius. So it does work without having the import active. It just is easier to have it active. So let's undo all those changes we just made. Save. And we're good. All right, let's swap back over to our course. There we go. Okay, so we do know that java.util is the package, scanner is the class name, so we'll continue from there. Now we're going to talk about declaring variables. In the sample above, lines 7 through 9 contain variable declarations. So right here, double, and scanner. Okay. So since Java is a statically typed language, we must always declare the data type for any variables. Lines 7 and 8 establish that Fahrenheit and Celsius will be double, and 9 is an input that references a scanner object. So if later in the code we try to initialize Fahrenheit with a string, the compiler will throw an error because the Fahrenheit is already declared to be a double. Okay, the following error is common for new Java programmers. Sometimes we forget to include the declaration for Celsius. What happens when we try to compile and run our program? So for now, let's just remove line 8 and click run. So let's try that. There we go. We'll comment out line 8. And now let's go ahead and try to run. Okay, so we got some errors. We can't find symbol variable Celsius, which is right here, and it happened to error out twice. So let's go back to our course. Okay, so we did get these exact same errors here. These two compiler errors run before the program runs. The value in the parentheses give the line and number and text column where the error was found. In the first description, the Celsius variable before the equals is flagged. When this type of error occurs, it usually means the variable was not declared. So the second line occurs because we use Celsius before it's been assigned a value. So we essentially have two issues when we remove this. The first one is that we're trying to, let's see, we have it in lines 16 and 17. We have it on line 16 because Celsius has never been declared. And then we have it in 17 because we're trying to use Celsius before it's been assigned anything. All right, let's continue. Let's see. Okay. When using an IDE such as IntelliJ, your work is typically checked by the IDE's built-in compiler as you write your code. Errors are often visually indicated by the IDE as you type. This avoids having to explicitly compile your code before finding errors. So IDEs are extremely helpful and extremely useful. Just pay attention to the color coding as we've learned before. And the red coloring of the Celsius variable indicates errors. The general rule in Java is that you must decide the data type for your variable first, then declare that variable before you use it. There's much to say more about the static typing of Java, but for now that's enough. And as in other languages, Java allows you to declare and initialize your variables in the same line. So you can theoretically do this, it's just not best practice to do so. And let's actually check this out. So let's undo this. Hang on. There we go. Y'all should be able to see my screen now. gun. Okay. How about now? How about now? Okay. Antonio, how long have you been listening in? I'm trying to see around what time my audio went kaput. Let's see. Does anyone know how long my audio was down? Question mark. Okay. And now we wait. Your audio went away right as I said it. Okay. So that's fine then. We were just talking about comments. So as programs get bigger, they get more difficult to read. Good programmers make their code understandable to others, so as readable, as close to English as possible. But of course, certain issues do happen. So sometimes we also might need to isolate our code to see what's working and what isn't. Essentially, this is the same thing that we've done in the past with our JavaScript course. So for now, we can comment out. To comment out sections of code, you're going to use these two, this at the beginning and this at the end. To comment out just one line, you just use the double forward slashes. So let's comment out the line, which would be, let's see. Yeah, that'll work. All right, let's just try this out real quick. Let's see. There we go. Okay, so simple enough. First of all, your comments have to be at the beginning of your line, not at the end. So if I comment out here and then type something, you'll see how all of this is gray. That's because it's been commented out. It's no longer actually being acknowledged. So our comments have to be at the beginning. Oh, I love that. Okay, so there you go. That's the way a single line comment works. If we wanted to do a multiple line comment, we would just do /*. Now, as you can see, my entire length of code went dark. That's just because I defined the start of the comment. I never defined the end, so it doesn't know where to stop. It's just commenting everything. In order to define the end, you just do a * and a /, and boom. Now whatever is wrapped between these two identifiers is commented out. For now, we'll just undo that. And save again, and we'll go back into our actual browser. Let's see, there we go, and there we go. What is this? Let's see. Okay. Never mind. Okay, so collecting input with the scanner class. In Java, scanner objects make getting input from user, a file, or even the network relatively easy. For our temperature conversion program, we have the input to be a scanner input. We want our program to prompt the user to enter in a number in the command line. We create a scanner instance using the word new, so input equals new scanner. Then we call the constructor and pass it the system.in object. So the system statements we've been using, system.in asks for input, system.out.println actually prints something out into either the web page or the the terminal, whichever we're using. System is technically a Java class. System.in is similar to system.out, except it's used for the opposite, which is a little funky to look at, but we'll continue. So we had something similar to scanner in JavaScript when we were asking for input. Can someone in the chat tell me what that was? Input.question. Good stuff, Antonio. Okay, so let's continue. If you're wondering why we must create a scanner object to read data from the system.in when we can write data directly to system.out using println, you're not alone. We'll talk about the reasons why this is so when we dive into the Java streams. So line 12 asks the users to enter a number, and line 13 we use input to read the value. So here system.out.println, enter the temperature in Fahrenheit, and Fahrenheit equals input.nextDouble. Now here we see the implications of Java being a strongly typed language. Notice that we have to call the method nextDouble because the variable Fahrenheit was declared as a double. So let's see if I can pull this up. There we go. So here we use input.nextDouble because Fahrenheit was originally declared up here as a double. If it had been a string, it would have been next string, etc., etc. Just wanted to show that to everyone. Let's continue in our course. So because Java is a statically typed language, we must call the appropriate scanner object to ensure the entered data is of the correct type. In this case, the compiler compares the types for Fahrenheit and input.nextDouble and throws an error if the two do not match. So if we were to pass a string, it would actually throw an error, and we can actually see that in play right now. Let's see. Where is it? Not there. Yes, there. Okay. So let's go ahead and run this. And now let's pass in, instead of a number, let's pass in piece. We hit enter. So it threw an error because it was actually expecting a double and we returned a string. Easy enough, right? Okay. So here we have some of our scanner methods. We have hasNextInt, so returns true if more data is present. Well, hasNextInt returns true if the next item to read is an int. HasNextFloat is for float, double for double. NextInt returns the next item to read as an int data type. So here we're doing some conversion. Technically it is conversion. So nextInt, nextFloat, nextDouble. Next just returns everything as a string, and nextLine returns the next line to read as a string data type. Closing scanner. To collect data from the command line or another source, create a scanner object. This opens up resources in your machine to manage the input. Leaving a scanner open is like keeping a window open in your house 24/7. Anyone can climb into your home and you lose money by trying to heat and cool your space while it's open to the outside air. Similarly, an open scanner can allow unintended access to your program and ties up resources. Best practice state that if you open a scanner object, close it after it finishes its job. So line 14 does this with input.close, and if we go back and confirm, let's see. Line 14, it does input.close. Remember, input is our declared scanner up here, so it does make sense. All right, let's continue. the general syntax is scanner object name dot close, which is what we have. So moving beyond the command line, the scanner class serves as a kind of adapter that gathers primitive data types as input and converts them into object types. So converts int to an integer. We'll discuss that purpose later, but for now, just know that it's an adaptation that makes low-level data types easy to use. For the temperature conversion program, we collected user input from the command line, but there are options for collecting data for our programs. We can see in future examples that creating a scanner object by passing a file as a parameter instead of a system in. So check your understanding. Question 1, an import statement is required to use a Java class defined in another package. True or false? And I will ask this to Mr. Watkins if you're still in chat. He ran. It's on the screen, man. An import statement is required to use a Java class defined in another package. True or false? True. Okay, so, let's see. Let me confirm something before I tell you the right or wrong answer. I'm not 100% sure on this one just because we did technically access the, what do you call them? Which one was it? Right here. So we did technically use java.util.scanner without importing Java. We did use this particular piece in order to run without having to import it. So I would say that's more on the false side, but you can fact check me on that. And let's go to question number 2. Which of the following scanner methods should you use to return an expected string input? Check all that apply. So this would be next and next line. Just because, remember, next returns as a string data type. Next line returns the next line to read as a string data type. But has next is just a Boolean, so it wouldn't really necessarily be too worried about it. Let's continue. More data types. Let's see. Ooh. Last leg of the stretch. And this is why I really wanted to do this with everyone. I think Antonio, I think you're the last man standing here. The reason why I wanted to do this with everyone was because it's going to start throwing a lot of information your way very quickly. As you can see here, we've gone through like 2 pieces of this chapter, but it's already been a huge data dump. So I want to make sure that you all get at least some level of explanation before you're tossed to the wolves. So arrays, nothing new to us. In Java, an array is an ordered, fixed size collection of elements. To comply with static typing, the items stored in an array must all be the same data type. We can create an array of integers or an array of strings, but we may not create an array that holds both integers and strings. The syntax for creating an array capable of holding 10 integers is int, and the array is note card time. What Is that Antonio? Question mark. While we wait for him to reply, let's continue. So int sum int equals new int, and then here you have the length 10. So the square brackets next to int tells Java that we want sum int to store a collection of integers instead of a single number. To create an array of a different size, replace the number 10 in the brackets with the desired size. To create an array holding a different type, replace int on both sides with either double or string. Hang on. Let's see. Let's continue. My apologies, got a different text. So int some other ints. This is how we can initialize an array using literal expressions. So int some other int equals 1, 1, 2, 3, 5, 8. Here, the size of an array is implied by the number of elements in the literal expression. So here we have 1, 2, 3, 4, 5, 6. And here we use curly brackets, braces instead of square brackets. To access the array elements, we use square brackets and zero-based index. So this is us accessing it. This is us initializing it. So arrays in Java may not change size once they're created. This is limiting and not very practical. Thankfully, Java provides more flexible ways to store data, which we'll explore in a later lesson. These objects allow us to rearrange, add to, or remove data. Aside from using arrays to build simple loop examples, we will only use them in special cases. However, they're a core part of Java, so it's good to know arrays. Java objects. So objects, another piece that's not new to everyone here. We should already know about these, but let's continue. Oh. Antonio, why didn't you tell me that my browser wasn't showing? That will be reflected on your next grade, man. Sorry, I was actually reading through this entire thing right here, and I hadn't even noticed that it was blocked off, so my apologies to you all. But yeah, just went through the arrays. Fairly simple. To declare an array, you have to specify the length, which is right here. To specify the type in the brackets. To initialize it, you do int some other ints. Here we use curly braces instead of square brackets. And to access array elements, we use the name of the array and brackets. And here we will actually use our zero-based index. So 4 would be the integer 5, because 0, 1, 2, 3, 4. Okay, now that you're all caught up, let's go ahead and continue with objects. There are structures that have a state and a set of behaviors. The state of an object includes properties and data that the coder can manipulate, can define and modify. Behaviors are actions that run when requested, and they can be used to evaluate, manipulate, or return data. An array is one example of an object. It contains data, which are the values stored inside of the elements. The behaviors are methods like sort that perform actions related to the elements in the array. The string data type is also an example of an object. For string, language equals Java. The data would be the characters. The string manipulation section gives several of the behaviors available in the language. For example, language.length returns the value of 4, which is how many characters are present in the string. Every variable in Java refers to either a primitive data type or to an object. Okay, class types. A class is a template for creating objects. In addition to the object types introduced so far, any class in Java also defines a type. We'll have much more to say about classes and objects, but for now, you only need to recognize the basic syntax of class types and class creation. So if we have a cat, we can declare and create a new instance of cat using the keyword cat myCat equals new cat. So cat myCat declares the variable myCat and sets it to be the type of cat. Equals new cat initializes the variable with a new cat object. And any arguments that are required to build a new cat must be included within the parentheses. Just like a variable can be declared as a primitive data type like car or double, it can also be specified as a, hang on, I'll be right back. All right, my apologies for that. Just had to go check on something. So yeah, where was I? Oh yeah. So just like any variable can be declared as a primitive data type like char or double, it can also be declared as a specific class type. Variables that hold objects like string name equals Blake or my cat are said to be reference variables. Using this terminology, name is a reference variable of the string class, and my cat is a reference variable of type cat. So Java uses two general data types, primitive and object. A class type is not a new data type. Instead, it's just a specific name applied to a more general object data type. Int and char are both primitive data types, but the values they can store differ. Similarly, string and cat are both object types. They just represent different classes. Let's see. Go. Okay, so let's continue. Reference variables. Reference variables are different from primitive types in an essential way. A reference variable, such as my cat, does not actually store the object in question. Instead, it stores a reference to the object, which is literally just a memory address. We visualize a reference as an arrow pointing to a location in the object of memory. So int my first cat age equals 11, int second cat age equals cat first age, cat my cat equals new cat, cat same cat equals my cat. So we have first cat age, which is 11. We have second cat age, which is also 11. And then we have cat my cat equals new cat, which is right here. And cat same cat, which is the same as my cat. So cat my cat looks at the cat data. Cat same cat also looks at that same data. They both point to the very same core concept and information. Since int is a primitive, the variables first cat age and second cat age function like separate boxes, each one holding the integer value of 11. On the other hand, my cat is a reference variable. Since it refers to an object of type cat, the variable actually stores the memory address of the object, which we visualize as an arrow pointing to the variable box. Instead of holding the actual cat data or being a copy of it, it's actually just an arrow that stores directions for finding the cat data in memory. When you assign my cat to another variable, as in cat same cat equals my cat, we don't create a second copy of the object or data. Instead, we just make an arrow pointing to it. The distinction between object types and primitives is important. As you continue learning Java, you'll see that object types are handled differently and in essential and more important ways. Okay, so static methods. If you're familiar with another programming languages, then you most likely define and called functions, which we have. As a pure object-oriented programming language, Java also uses functions, but it structures them in a very specific way. In Java, functions may not be declared outside of a class. Even a simple function that checks if an integer even needs to be defined within a class. So within the context of a class, functions are referred to as methods, and we'll adopt this terminology moving forward. So be prepared for a vocabulary lesson from a veteran Java coder if you accidentally refer to methods as functions. So we'll dive deeper into classes and objects in Java soon enough. For now, we'll explore how to write methods. In particular, we'll use static method. Static method is one that can be called without creating an instance of the class to which it belongs. So here we have public class cat. We have our void. And since make noise is static, we don't need to create a cat object to access it. We can do cat my cat equals new cat, which is where we create the cat object. Then we do my cat.make noise equals purr. So instead of doing this, we just do cat.make noise roar. Until we get further into object-oriented programming, every method you write should use a static keyword. Leaving off static will prevent or complicate the process of calling methods you define. We will explore what static does in more detail in later lessons. And static methods, we'll examine 2 Java classes to explore defining and using methods. The first class is defined in the hello methods Java file and has a main method. The second is in a separate message.java file and contains a get message method that we want to call from within main. So hello methods.java is a public static void main. So string.message equals message.getMessageFR, system.out.println message. And message.java is just a get message. So if the language dot equals sp, it returns hello world in Spanish. If it's fr, it returns bonjour le monde in French. And if it's none of those, it'll just return hello world in English. So let's continue. We won't explore every aspect of this sample, but we'll focus on the 2 methods. The main method in hello methods has the same structure as that of our temperature conversion class, which it does. Let's see. Yeah. Take a look at the message class. Notice that it does not have a main method, so it can't be run on its own. Code within the message class must be called from somewhere else to execute. The message class contains getMessage method right here. Like main, it has a static keyword. Unlike main, getMessage has a return type of string instead of void. And getMessage takes a single string parameter, language. Since Java is statically typed, we must declare the data type for each parameter and return the value. So public static return data type method name, blah, blah, blah. One consequence of this is that a method in Java may not have a return statement that send back different types of data. Note that lines 6, 8, and 10 in message.java return a string. If we try to replace line with return 42, we generate a compile error. To call a static method, we just follow the simple syntax. So we do message.getMessageFR. To call a static method, we have to use the format class name dot method name and pass in your arguments. Notice that getMessage is not defined in the hello methods class. We can do this because getMessage is declared as public. Okay. If we wanted to restrict the method from being called by another class, we could always use the private modifier, but we'll get into that later. So we've been following along with those examples, but we've noticed that each class file, so message.java and hello methods.java, is named exactly as the class it holds. It's a rule in Java that a file containing a class marked public must be named the same as that class. Simple enough. Okay, try it. Open the hello methods and message files and experiment with the following. Figure out how to alter the hello methods code to change the message returned, add another hello world language option, and change one public keyword to private. So we can do that real quick. Let's see. So let's go ahead and just, where is it? Hello methods. Okay, that's fine. Message. So our requirements were to alter the hello methods code to change the message returned and add another hello world language option. So here is simple enough. We will just do, if we wanted to add another parameter, we would do, remember, we have if, else if, and then else is a catch-all. So we'll do else if, and we will do lang dot equals, and here we'll do, let's do let's do JP, and here we will return, and let's just Google real quick how to say hello world in Japanese. Oh, it's a movie. We will return Konnichiwa Sekai. Now, very important piece here. If you noticed how we have this little red line right here, it's because we didn't close out our lines. It's very important that you close it out with a semicolon. And just for readability's sake, there we go. We'll save. We will go into hello methods. We'll run this. And let's do so the static was French. Let's change that to JP. And now let's run it. So now we got Konnichiwa Sekai. What we did was we just changed the hello method to get a different output, which is what the first piece was. And we also figured out how to get a different return for a different language in our code. 2 birds, 1 stone. Simple enough. Let's go ahead and continue back with our code. Oh, that is weird. Okay, that's weird, but okay. All right, so check your understanding. Which of the following defines a method that takes an integer as a parameter and returns a string value? So public static void method name. Let's see. So if we look back up here, public static string message name string lang. So string is the type that it'll return, and string lang is the type that it's expecting. So for this particular instance here, we would actually want to do, it needs to take an integer as a parameter and return a string. So this would be D, public static string method name. It's going to return a string, and int parameter name. It wouldn't be void because remember, we are returning something. So these two are automatically out. Int string parameter name wouldn't necessarily work because our parameter is going to be, as stated up here, an integer. All right, assume we declare the following Java array. String some words equals new string 5. Which of the following shows a correct initialization for the array? So some words equals, this is a good one. This is a very good one. So this one right here would be B. Just because, simply put, remember, the single quotes are only used for character types. So this is out. We have one stray character type right here. And this is 1, 0, 1, 2, 3, 4. This is 4 lines, not one. Oh, they're both 4. That's weird. What's wrong here? Let's see. It's all good, all good. Thank you for joining. Let's see. So the reason why it would be B, hello world, 1, 2, 3, launch code word rocks Java. Yeah, so there are 5 strings here. So yeah, that does make sense. All right, so the time is now 9:41. We've been going for about, how long have we been going for? Let's see. Looks like it's been about an hour, 12 minutes. We're actually going to go ahead and do the data types exercises because they're not too difficult. So the instructions, we work on these with our Java web dev exercises. We create a new class for each number exercise, and we can name the class whatever we like, but we have to use the proper naming conventions. So first we create a package and class. So let's just do this. I wonder if it'll actually let me. 1, 2, and oh, nope, it doesn't. Let's see. Okay, that'll do for now, I guess. Okay. So, let's see. Okay, so first we have to go into the source folder, which we already are, and we'll right click and do new, and we'll do a new package. We'll call it exercises. So here we have our exercises now, which is step 2. We'll right click on the newly created exercises folder, select new and Java class. So right click, new Java class, simple enough. We will name this what the name of our class will be. Let's see. All right, Antonio, not a problem. Go ahead and try. Yes, actually, that's a great idea, Antonio. Go ahead and try to do this individually, and then once you I'll cut the stream into 2 pieces. One that is up until the actual assignment, and then one that is the assignment solutions. That way you can review that later. Thank you for coming out, Antonio. Appreciate you.